Okay, so we're just going to look at differentials of graphs. So we did this a good while ago, but just to recap over it. So differential means differentiation, obviously. So just kind of recap on what we talked about before. So I'll just get a pen here. So like if we have a cubic graph and we differentiate, so like that's like our x cubed, it becomes quadratic, which becomes x squared. So we just say what we did there, dy dx. If we differentiate our quadratic graph, it becomes linear, which becomes, so if we find dy dx of the quadratic graph becomes linear, which is just an x. We can show this in examples, like if we have x cubed, so if y is equal to x cubed, then dy dx is equal to 3x squared. So our cubic became quadratic. If y is equal to 3x squared, so we start with our quadratic, dy dx is going to bring down to multiply by what's there and reduce your power, so we get 6x. So your quadratic becomes your linear. So that all makes sense. So if we have a cubic graph, if we know cubic is like this, so we differentiate our cubic graph, it's going to become quadratic, and then differentiate our quadratic, it's going to become linear. Right. So if it ends high, just remember this, if it's cubic and it ends high, it's positive. You know U shape is positive, and then obviously going up is positive. If we have a cubic graph that ends low, ends low, it's negative, therefore quadratic is negative, and the slope and the linear will be negative. So there was a few rules when we had the graphs. So if I'm just going to draw up, actually we might look at the example above and recall these rules. So as we can see from this graph here, so it is, and we have a worksheet on this on Edmodo there somewhere. As it's increasing, it's a cubic graph. You can see that because it's a strange shape. It's like a squiggle. It's always increasing. That's the first thing that we notice. I'll just write that here. It's always increasing. Therefore, the differential of it will always be above the x-axis. So we know it's cubic, so we know when we differentiate it's going to be quadratic, right? So it ends high, therefore we know it's going to be positive. So straight away we know that, well, b is gone and d is gone because they're both negative, right? And then what I'm talking about here, so it's always increasing, so we can see that, so from here to here it increases, it always increasing, therefore it never drops below the x-axis. So when it's drawn, it should always be above the x-axis. If we had a cubic graph, say that did this, something like that, or actually that might even confuse you, you might just go something like that, okay? It's increasing this side, then it's decreasing in the central part, decreasing there, but then it goes back to increasing. So if we have that on our quadratic graph, then increasing, that means it's above the x-axis. So for this part here, I'll just put the lines through it. It's above the x-axis. But this yellow part here decreases, therefore it means it has to go below the x-axis for that decrease. And then again it increases, so therefore it comes back above the x-axis. This ended positive, therefore it was U-shaped. Hope that makes sense. So if we go back to what we were looking at then, now, so it was increasing, so just looking at the graph here, increasing all the way. Therefore it's always going to be above the x-axis. So we look at our options that we have now. As I said, we eliminated B and D because they were negative graphs. So looking at A first. So A is, in a cubic graph, it should have been increasing from here to here because it was above the x-axis. But then it decreased. So did ours ever decrease? And then it starts to increase again. Well, no, ours was always increasing. There was no dip to make it decrease at any stage. So it was always increasing. So A is gone. And then just to make sure C is correct, C was increasing all the time. So it never dropped below the x-axis, therefore it was never decreasing. That makes complete sense with what we have. It ends positive, therefore the graph is positive. C is a positive graph. Therefore our answer is C. And our justification, so we've loads of justifications. So cubic becomes quadratic. Then it's always increasing. Therefore the quadratic, so cubic is always increasing. Therefore quadratic is always above the x-axis. The cubic graph was positive. Therefore C is the answer, as C was also positive. So I know that's bad writing, but I hope you get the idea of it. We're just going to look at the other graphs here really quickly, just to make sure. We're just going to recap on like what would they look like if we had to draw them, if we had to do it the opposite way. Although I know we'll probably never be asked to actually draw corresponding graphs, it's really good to, if we understand that, we'll understand every type of these questions. So, for example, we look at A first. So if I draw A as a cubic graph, right? So I know that it's increasing from here to here. Then at some stage it's going to be decreasing, and then it will increase again. So I'm going to draw increasing, then it decreases, and then it increases. That could correspond to A. The decreasing part is from here to here. It ends positively. Therefore it's U-shaped when it's quadratic. The decreasing part just represents that line in there. So there represents there. So this one's negative. So if we draw our negative, so but what happens this one? So I will just have to draw that again. It's negative. It's always below the x-axis. That means it's always decreasing. So it's going to look something like that. Okay, and it didn't have to be drawn below the x-axis in this case, but it always had to be decreasing. There was never a stage where this graph was increasing. C, we obviously have it drawn there, and D, so we know it's increasing from here to here, then or decreasing, sorry, because below the x-axis. Then it will increase, and then it will decrease, right? So if we have our graph, so we go, so it's increasing, then it, oh sorry, no, decreases first, sorry, that makes sense. So it's decreasing, then it increases, and then